All right. That's a good start to that video. Here we go. So we've got a table that gives a set of outcomes where it says, let event A be the event that the outcome is less than or equal to 5. The event B is the outcome is greater than or equal to 5. It says find the probability of A given B. Let's write down that formula. Remember, you will get this from me on our test and on the AP exam. All right. The denominator is going to be the probability of event B. Right. That's the given. All right. In the numerator is the probability that they both are happening. Okay. So let's try to figure out the denominator first. Probability of event B. Event B says that the outcome is greater than or equal to 5. Guys, what are numbers that are greater than or equal to 5? 5, 6, 7. We don't need to keep going, right? So 5 and 6. So these two. So those two probabilities are going to go in the denominator. Everyone okay with that? You good? Okay. Now this is where it gets a little tricky. So I'll try this, see if it works. Okay. We need to figure out where they're both happening. So I'm going to highlight event A, which is the outcome is less than or equal to 5. So what events here would be less than or equal to 5? 5, 4, 3, 2, 1. Okay, ready? 5, 4, 3, 2, 1. Again, backwards. Oh, man. Because I should have used yellow on top of it. Does that work? Anyway, I was trying to show you that one of them is both. Do you see which one where it happens where it's both yellow and green? And that's the 5. So that's the only one that's both. So that's the only one that gets to go into the numerator. So the numerator is 0.186. Okay? Everyone okay with that? Should I do it again without colors? Do you want to try without colors? Since you might have colors? Okay, you're good? All right. So let's use the calculator. It's got 0.186 plus 0.014, which is 0.2. Divide that by 0.2. You get 0.93. Now, this is not one where you have to like reduce any fractions. Or we actually have decimals here. Okay. Questions on the first one?
I don't understand why you always put 5.
So the first outcome, event B, says greater than or equal to 5. That's these two.
Oh, okay.
Okay.
Oh, okay.
Can I just finish this up? Okay. Event A is it's less than or equal to 5, and the only one that's boxed in both of those is 5. 5 is the only one that's part of both. Okay. Let's go number 2. Same thing. Obviously, it's going to be different probabilities here and different type of problem, but it does say find the probability of A happening given that B occurs. So my denominator is B. My numerator is A and B. So let's start with B. B is the outcome is prime. The outcome is prime. Do you guys know prime numbers? That was a lot there, Dylan. Not 1. 1's not prime. 2. Not 4. 2, 3, 5. I think we can stop, right?
2, 3, 4, 7.
We can keep stop. We can stop. Okay. So I heard 2, 3, and 5 are prime numbers. So let's put those in the denominator. So 0.1 plus 0.6 plus 0.1. Now the other one is event A, which is the outcome is divisible by 2. So what numbers up here are divisible by 2? 2 and 4. So which one, and I finally did the colors right. Sorry, colors weren't my best in kindergarten. But you see which one became green? That's what I was trying to do in the first one, but I failed. All right. See what I did there? I finally got it right. My next recording, I'll get it right. All right. Cut! Okay, so I was just joking. Okay, whoa. All right. So what am I putting on the top? 0.1. Are you okay? Are you okay? I am. So whatever 1/8 is, is it 0.125? Yes. Well done, Taylor. Okay, how's everybody feeling about this? Everyone feeling okay? Honestly, I think the hardest part you'll have is just like remembering what prime numbers are, divisibility rules. Like I think that actually will trip you up more than the actual like probability stuff.
You should give us highlighters.
Oh, great. Next year. Okay. Let's do number 3. Number 3. It's going to feel similar, but notice there's no table, right? It just gives us fractions. It says, what is the probability that events A and B both occur? It's too late. I'm sorry. We have less than 10 minutes. I'm so sorry. Go fast. I'm glad I'll get to look back on that fondly in 5 years. Okay. It's okay. No worries. Just making a joke like when I watch this video again. Full strategy on. Okay.
That's mean.
All right. I'm not here to debate that. I'm here to help you with some probability. All right. So this is the formula we've been using, right? So what I was trying to tell you guys yesterday in the lecture portion very quickly was I'm not going to like memorize a new formula. I'm just going to figure out what I know, plug in the stuff I know, and there should be one that I don't know. And I'll use algebra to find it. Okay? Is there a question? All right. So first off, which one am I trying to find? Which one am I trying to find? That A and B both occur. So the numerator, right? The numerator? I'm trying to find this one. So did they tell me everything else? Did they tell me the conditional one, A given B? Yeah, that's 2/3, right? Yes, everybody see that? That's 2/3? Yeah. Okay. Did they give me the denominator? The probability that B happens? Yeah. That's 3/7. So can I find this numerator? Yeah. Yes. Now I know it's going to feel like I'm doing like some weird algebra here, but I know it's a fraction in the bottom. Imagine that denominator was just 2. How would you move that 2 to the other side? Times 2. So I'm just going to multiply both sides times 3/7. That will move it over. And then I'll be left with my answer. Yes, we do need to reduce, or in this case, cross out, right? Do you see how the 3's will cross out? Yeah. Right? 3 divided by 3 is 1. So I'm left with 2/7. No worries. So you're going to see some different types of questions on this link, right? Some with the table, some without. Sorry, go ahead. Almost done. One more. Last one. Last one.
Is there going to be a question where like it asks you where you have to plug back in what you find into the given equation?
Into the original up there? No, in these, I think they're going to give you 2 out of 3. They should give you 2 out of 3. But let me know if you find one that it doesn't. I'd like to see it. Okay. So write down the formula of the probability of A given that B occurs is the probability of A and B occurring divided by the probability that B happens. All right. So which one am I trying to solve for? A occurs given that B occurs, so which one is that? On the left side, right, of the equal sign, I'm trying to solve for that. Did they give me the probability that both are occurring? They did, 1/6. Did they give me the probability that just B is happening? What is that? Nice. Now here, I am going to make that look a little nicer. That is a complex fraction. So I'm going to write this as 1/6 divided by 3/8. How would I rewrite that using multiplication?
1 times 8.
I'm going to go ahead and use the math definition there, which is multiply by the reciprocal. Sure, multiply by the reciprocal. All right. Can I reduce anything? So 8 and 6, right? What's 8? Both of those can be divided by 2. What's 8 divided by 2 is 4. 6 divided by 2 is 3. Now you can multiply straight across. and get 4/9. Could you have multiplied straight across to get 8/18? Absolutely, but is 8/18 reduced? No, you do need to reduce 8/18 then to get 4/9. I don't care which way. I teach my children to see if you can reduce diagonally first before you multiply across. It'll save you headaches in the future.
So we have to reduce.
In